So what I wanted just to spend a few minutes doing is just introducing who I am, to try and make it a little bit more personal. So I've been in the construction industry for probably 30 years now, and that makes me sound quite old. I started off as a CITB technical apprentice. So recently, as Sumit has said, head of design for Crown Ice Technologies. That includes MEP design for Lang O'Rourke. I'm president of the Building and Engineering Services Association. That's the BNES board. I grew up in Stoke-on-Trent. I think that might be my year picture from school. I'm not sure. Can't recognise myself, but it's there or thereabouts. And at the time when I went to school, one of the real working class area, and all my predecessors in my family worked in the mining industry. So we were destined really to go and work in the steelworks and mining. There's Michelin tyres in Stoke. So that was kind of where we were all heading when I was in that year in 1984. Then a few things happened in the early 80s that have stuck in my mind. That's the Challenger space shuttle, and that is 1982, which when you look back is quite incredible. So I'm there destined for a career in mining, some form of mining apprenticeship, and we have the day off from school in 82 to go and watch this thing take off. And to be honest, I think even today, with all the technology that we've got, that is an incredible achievement. So that's the first thing that sort of shaped my thinking and where I am today. So that's for somebody. So somebody that likes modernisation, that is so British, and I'm quite embarrassed about that, but I thought I'd put it up. The other thing that happened though was and the picture's not come up, was what Margaret Thatcher did. So Margaret Thatcher, back in 83, 84, she completely had a modernisation agenda, and that really changed the direction of travel, which my career has taken, and that of a lot of other people. So we've been brought up really from a background where everything changed. So everything that I knew and understood as a young teenager changed. And that's kind of where construction is today, and where it's probably been for the last probably 5, 6, 7 years, if we're being honest. So BIM means different things to different people. I don't think there's any real rules on what that means. One of the difficulties I've got today in addressing you guys is that I'm not a BIM user. I'm not a software techie. I can't talk to you about the level of detail that's been presented to you guys today. But what I can do is talk to you about my experience of leading a large design team back in the UK, about what we're trying to achieve as a design team, what we're trying to achieve on our projects. So that's really what I'm going to share with you today, and also what we're doing within our business, what we're doing within the UK construction industry. There's lots of different ideas, and I think some of it will sit nicely with you guys. So what I'm passionate about is how we create value. There's been a lot of talk today about how BIM allows us to deliver complex projects. That sits difficult with me sometimes, because I think we've been delivering difficult projects for the last 100 years. You know, when you look around London, I'll give you some examples. St. Paul's Cathedral, when you understand how that was built, absolutely fascinating. Could we do it today? Possibly not. The Houses of Parliament, if anybody's been in there, that's a wonderful example of what is great about the construction industry. In more modern times, Terminal 5, and I know from the people that I've met here that some of you have worked on that project. That wasn't a BIM project, it was a 3D project. Terminal T2A, which we've just completed, again, that wasn't a BIM project, but it was a great example of 3D modeling. I think there's a lot of focus on software. Sometimes I think we focus too much on the software rather than what the outputs are going to be. And we also have to remember that we have to create great design concepts and then we also need to go and deliver projects, and we need to get into detail to do that. But what BIM allows us to do, I think BIM is putting the drawing board back into the office. So as a young engineer, I started life on a drawing board. A drawing board was a tool that people could come and stand around. Didn't matter who it was. You could get the supply chain in. He'd stand there. And he might even do the takeoff for you. Clients would sit and look at what you were doing. You would get your site foreman really interested in what you were developing and drawing to see if it was something he could construct. So the days of the drawing board, for me, there is great visibility, and I think the drawing board is a great collaboration tool. What I'm seeing today is BIM is the replacement for that, and it's been a long time coming. There's been a lot of talk about data. Data is absolutely key for where we're going to get to. We've been talking about where we sit in the whole supply chain, about how we're going to deliver projects, about how we create design. We've been talking about QA. You know, there's lots of different strings to what BIM is. But for me, one of the most important aspects that it's about people. People are driving this agenda. It's about collaboration, and it's about driving efficient change. So this is my perspective, leading a design team and where we've come from. And if I can turn the clock back probably 5 or 6 years, we have people in our sector that are interested by technology, that are driven to try and do things differently. So this whole BIM revolution, how I see it through my lens, started off with individuals going out and seeing something that was different and trying it almost on the QT. What then happened, that engineers in the industry that wanted to do a different thing started to form groups, specialist interest groups, and the BIM journey started. That could be a design team today, couldn't it really? All sharing information along that beam. The UK government has an agenda, and the UK's government agenda is quite interesting. So what they talk about is using data to enable efficient ways of working. That's pretty much, as you go through the document, the first thing that you pull out. The next thing that we should be looking to use BIM to enable design for manufacturing assembly and lean construction. We should be using BIM to reduce asset costs and to drive operational efficiency. We should be using it to drive supply chain efficiency. And the most important aspect, we should be using this technology and our skills to drive growth in our sector. That's my summary of that document. So in terms of how this sector is transformed, that building there is Millbank Tower in London, constructed by John Molan, and I think it was completed in 1963. It's one of the few listed high-rise buildings in London, 180 metres tall, 70,000 square metres, 33 floors. And the MEP in that was quite simple. We then go on to where we are today. So the two images that you can see at the top is the Leadenhall Street Tower. That's 48 floors, 225 metres tall, 85,000 square metres, and that was constructed in 3 years. The building below is the Aldar HQ in Abu Dhabi. That was completed in 2 years, 23 floors, 110 metres high. So what's interesting about that, if we go back over 40 years, that the industry is more efficient than it was. And if you just do the maths, back in the 60s, we were completing 17,500 square metres a year. When we completed Leadenhall Street, we did 28,000 a year. And the Aldar HQ, 31,000 square metres. and you can break that down into floors per year, and it's quite interesting. So we're probably twice efficient as we were 40 years ago. The other thing that's exciting about the industry, that what this technology is doing is allowing architects to be more creative. And what that does, it makes life much more challenging for us in the MEP sector. The building that's on the screen now is the Moscow School of Management. I don't know if anybody's familiar with that project. So I went to a presentation by the architects that came up with that concept at the RIBA in London a couple of weeks ago. And I found it all really interesting until he started to talk about the diameter of the bulk of the building. And that is 350 meters. So I doubt whether you could deliver something like that without the technology that we have today. Quite staggering, really. I don't know what the GIFR is, but it's huge. So some of those, that's probably getting on for 350 meters in length. That was recently, I think that was completed last year. Other great things that we're doing with this technology now, when we were looking at the town planning for the Leadenhall Street Tower, when you start to think about sight lines, so back in the UK, St. Paul's Cathedral, there's a number of vistas around the city that actually protect the sight lines. And there's 3 key areas. So which is why we've got some of these strange buildings. So again, this is back in probably 2005 that some of this technology was being used to actually look at the town planning and to start to set the form of this building. Now again, I was lucky enough to be in a meeting with the architects that came up with the concept for the tower, and it took them 6 years to actually finalize the form, the vertical riser at the back of the building to get the services up and down from the basement to the plant attic. It took them 6 years. So they were using this technology a long, long time ago. That's a superimposed image. So again, as the architectural form becomes a little bit more detailed, as the concept's being developed, the architects and the services engineers are using digital engineering and BIM technology to start to add detail to the concept. And that's what the building looked like in construction. So these are really powerful tools. So what we're finding is that clients' demands are ever increasing in terms of speed of construction, value that we offer. They want their buildings to be the shiniest, the brightest in whatever location they're being constructed. We heard a bit about that this morning from Victor. So we know that we've got clients that want bigger, better, and more. So how are we using the technology to keep up with the clients' expectations and also to exceed them? So we're now starting to use BIM technology to drive that. So these are sections from the Leadenhall Street Tower these are vertical steel sections. These are huge, probably 18 meters long, 4 meters high, and these come integrated with MEP components. That's the size of them going in. If you look at you can see the services embedded. There's a fan coil unit there, ductwork, grills, diffusers. They're wired, the controls are pre-commissioned. But what we started to use on the Leadenhall Street, the technology for, was one, to form a concept of how we were going to deliver this project on time, and also with the constraints of the site. Working in central London has many, many challenges, just in terms of logistics of getting components in is a challenge. We trialed BIM technology to actually track components as they were coming from all over the UK, having different components integrated. So we started to track with RFID tagging. We looked at coordination, we looked at build times, we looked at hook time for cranes, how we could contribute to actually having a really efficient lifting program. And we looked at it to how we could sequence the whole project. And we were doing this back in 2011, 2012. And I don't think we really celebrate what a success this project has been in terms of BIM. And it's just been about people like you guys wanting to trial the technology. BIM wasn't a client deliverable. The consultant drawings are in 2D. But again, it's due to the enthusiasm of people that work in the sector that want to try this technology. Just more of the same. So that was a huge success. Just what you can't see on there, each level as well also had a modular plant room. The modular plant room probably traditionally would have been fitted out by 2 guys in 16 weeks. These things went in a day. But also when you're working on high rise at that level, once you're so many floors above ground, until the cladding's on, it's not safe to work. So there's a huge amount of work that we were able to do at a really early stage. Again, a leap of faith by our BIM engineers and CAD team was to actually start to develop a model as we were bidding this project. So a huge success of the model was that it went and wowed the client. So when we did our bid presentation, we went and took the model. The model was on iPads. So again, you can see there, fan coil units, ductwork, containment, valves. So again, those were all pre-commissioned where they could be. I need you guys up there to play the video now if you can. Hey? Have I got the mouse? All right. So that's a little introduction to how we've been using BIM to drive DFMA on projects and just a smarter way of working. So the next area that we need to focus as an industry is how we influence our design partners and the design teams, whether they're internal or external, around how we can work smarter to keep up with the speed with which modern buildings are constructed. So this video is just showing how we feed this information back to designers. It does mean that we need to get on board fairly early. So this is the start of the process. So we get a hold of the consultant schematic and we start to block out areas that we think that there could be a benefit in producing DFMA off-site manufactured skids. That's the chill water. Heating schematic, pretty much the same. So this is thinking at a really early stage how you're going to build the project. And why this is crucial, depending on the procurement route for the MEP, that the frame could be almost complete by the time the mechanical and electrical contractor's on board. So a lot of decisions are being made. We need our design teams in our industry to be thinking about this at a really early stage. So again, I spend a lot of time going out to consultants, just talking to them about what can be achieved by working in a different way. So that's the work that we would do on a schematic. Then when we've got that this drawing is probably taken from a concept design. We would call it at RIBA stage 2, which is probably LOD 100 or something like that in Australia. So again, it's just about feeding back to the client and to the consultant areas that we can construct off-site. As the design gets more advanced, again, there's huge areas that we can construct off-site. So again, feeding this information back into the design team. So this is where it gets exciting. As the design develops and a model becomes available, we start to articulate this information in the model. So that was those schematics that we've just been looking at. We are now populating the model with placeholders to start to demonstrate what you can achieve by working in a different manner. So this type of work we would do ideally at concept stage. Because there's a lot of information in this that would start to inform structural loads, considerations for the architect. We're looking at zoning, space allocation for services. So again, this model's fairly dumb at the moment. It's been populated with standard component sets. I'll just move that on. So there's air handling units on the roof, ductwork, pipework distribution, which is the blue. Because traditionally, we'd only start to think about how we were going to construct something probably at stage E or F in UK terms, which is at probably LOD 400. So then we start to populate the model with data. So these are just labels to identify the type of data that we would put within the model. So where we think there's huge value in this is that it's the drawing board back in the office. You can go and have a conversation with the architects about what possible solutions are going to look like. You can go and sit down with the structural engineer. You can get the supply chain involved really early. You can set constraints for services distribution. So the work that's gone into this model is probably no more than a day's work in that, which I think is a really useful way to spend your time. So the other area that we're looking at is how we can develop our own products, our product templates. And when you're thinking about how you're going to manufacture off-site, there needs to be some controls and measures around that. So we have a technology readiness level and a manufacturing readiness level. What this does is create some constraints around what is achievable and what isn't. So again, what this animation shows you how we can take a standard component set that's one of our library products, and how we can start to dynamically modify that to suit the actual requirements on a project. So TRL, MRL is a QA procedure. Some of the outputs from the model are these components that you can see now. So these are manufactured horizontal distribution elements that now come from our coordinated model. Again, as Warwick was describing earlier, we manufacture, these are Revit models that we manufacture too. What's absolutely key for this to work is that when we receive a model from a consultant, that we have design data in it. And what I mean by design data is flow rates, ideal pressure drops. That's part of a modular plant room, very similar to what we did on Leadenhall Street. So again, we're using models for optioneering. This is part of a hospital project where we wanted to model the bathroom risers at a really early stage to see if we could manufacture it off-site. We use this to, if we can do it early enough as well, to feed back into the construction team constraints for the risers. More horizontal distribution. A really important area where there's a lot of value are, we call them in-room units, where you've got active equipment such as fan coil units, chill beams on pre-manufactured elements. Again, all constructed from a Revit model. Another example of a live BIM model. This is produced by Arabs in London. That's a Revit model with all the live equipment in the blue is all tagged. So some of it is generic, but it's all got the data attached to it. That's a variant of that. You can see the ventilation units, the lights, they're all products with all the manufacturer's data attached to it. That's an example from the same project where we have design data within the model. That's the only time we've actually achieved this. First time we tried it. And the guy that actually produced this doesn't think it takes any longer than it would by not doing it. So you've got a fan coil unit. We are getting bills of materials out of the model. A couple of years ago, what I said this morning, it was a nightmare. How accurate this is, I wouldn't like to say, but we are getting more detailed bills of materials. But data is absolutely critical. We need data in from the consultants. We need to populate it and add to that data, and we need to use it to work with the supply chain. So another need for data, contractually back in the UK, we're finding that we are getting locked into energy targets. So there's a lot of projects where actually BIM's not a deliverable, but to achieve an energy target is. So this is a big issue at the moment, and there's a lot of noise around this, around what type of energy is being used, how we can control it, how we can predict it. So again, regulated energy is probably that element. Unregulated is that, although we're not contracted to be accountable for that. But what it proves is some of the modeling that we're doing at the moment isn't that accurate. So again, we're looking to use a BIM model to help to drive that by populating with data, looking at occupancy patterns, looking at hours of operation. And that's why there's a need for data. The design intent, it says air must be robust. We need to be able to challenge it. We need to be able to look at it collaboratively across the design team. We then need to add to it through the construction process, and then we need to capture it in operation. I have no examples of where we're doing that at the moment, but we're trying really hard to do that bit. So that's some of the good stuff that specialists and experts are doing in the UK to try and move the agenda forward. One of the areas that we need to focus now is BIM an asset or is it a liability contractually? And I find this really interesting. And these are questions that we need to be asking ourselves. I don't know if we do that. Is that something that any of you guys consider? I think very much it's an expense at the moment from my experience. BIM possibly costs on the projects that I oversee could be anything between 1% and 3% of the MEP value, just because we're not working efficiently yet. That's going to come. But I think this is also, we've talked about the need for data. I think we need to talk about financial viability and how we're going to get value out of this as an industry. But I also think this is going to be a great tool for us to actually drive income across the life cycle of a project. We produce something that is so data rich, that is so valuable. And a lot of people are going to want this. As Victor said this morning, it's been said a number of times today, clients are wising up to this now that we are creating something that is hugely valuable. And once we've got the data sorted, once a model is complete and it is data rich, I think people will I think there could be an income stream from it. We have to get more leadership around this agenda to drive it forward and not to keep the momentum going. We need it to go faster. I think that is a view of a lot of people today, that BIM is seen as a liability and an expense. We need to get to that as quickly as we can, because as soon as we can demonstrate that, industry leaders in this sector will actually move this to the next level quicker than you could ever dream of. Every single person that's got this agenda to where it is today, you're the people that have created these opportunities. We need to start to think about how we're going to lead this, how we shape it to the next stage. I think we need to broaden our horizon. We need to be more strategic. And I think we need to have a view on what the future looks like. BIM is going to enable change. It's enabled change in the last 10 years. And And if you look at the speed of which people are adopting it, and it is quick, it's going to get even quicker and quicker. And what it is going to drive is a more efficient way of working, a safer way of working. It's going to allow us to develop much more complex projects. I want architects to come up with the weirdest and wackiest designs as they can to be energized and excited by what they're doing. And we in the MEP sector need to be able to go and solve their problems. This technology, this software is going to do that. There's a huge skills shortage in our sector, whether that's engineers, tradesmen, craftsmen. Huge shortage. By again embracing technology, I think that's going to help to solve. It's not going to solve the problem, but it's going to help to solve the problem. But this technology and this way of working will attract new people into our industry, people that probably wouldn't have been attracted previously. We are going to come under pressure from build times. I think build times, DFMA, off-site manufacture, is a little bit like BIM. It's being driven by people that are interested in changing the way that we work. I've been brought up with that. I think clients are going to demand that as time moves forward, like they're going to demand the fact that they want a data-rich model. They're probably going to pay us to go and maintain that model over 25 years. Clients are becoming more intelligent. Life cycle costs are starting to be a big issue in the UK. I don't know if they are in Australia or anywhere else in the world, but it's going to catch up if it's not. And we touched on it this morning. These guys are starting to wake up and smell the coffee and sense something that's going to add value to their business. When you look around other sectors, so I've been researching transport. And this is fascinating as well. Flying over on the A380 in less than 24 hours, I couldn't have done that 5 years ago. That was 24 hours with an hour and a half's delay. It's actually, the world's getting way smaller. An A380, something like £200 million or $300 million, and that is constructed and assembled in 10 to 15 weeks, and it takes 12 months to test, commission, and put it into service. And we need to start to think about that, because I think it just shifts the emphasis, doesn't it, on the construction time in our industry. What tends to happen? The commissioning period at the end gets squeezed and squeezed and squeezed. I'm seeing less of that now because people understand the importance of that. I think that is going to become more important. Clients are going to want to protect that. They're probably going to want longer to commission the buildings. It's happening in other sectors. What the A380 has done for Boeing is that they took the 747, huge threat the A380 was for the 747. I didn't know this either, that the 747 was designed in 2 years back in the 60s. I think it went into operation in 1968. And it was really inefficient. And it was inefficient because of the wing design and the engine design. What technology has done for Boeing has allowed them in a 12-month period to actually redesign the wings, redesign the engines. The 747 now is probably as efficient as that. It's a great design. It stood the test of time. And technology and the software and the inspiration that you guys have got is actually changing that business. And that thing there, that's the world's largest vessel. That is 1/4 of a mile long, built by Daewoo. I can't believe this either. That's $200 million. So what all these manufacturers have done, they've halved the emissions from all of those pieces of kit. That there, per container, is twice as efficient as what it's replaced. That is built in a year. Comes in about 500 bits. Built in a year. It's absolutely unbelievable. And it's done by using the same technology that you guys have got. That's called the Triple E. And I think this is great as well. That Triple E stands for efficiency, economy of scale, and environmentally improved, which is exactly what we're doing in our sector. So I think that what we're starting to see in other areas of industry is going to come It's going to come to our door, and it's going to come really quickly. And the future is going to be fantastic. So I think you've done the groundwork. Industry's done the groundwork. There's been pockets of excellence. We need the leaders of our industry now to embrace this and take it to the next level. I don't think there's a silver bullet. Over the last few years, we've talked about, is that going to be software? Is it going to be process? I think it's everything. You know, there's no rules to this. What it needs is passion, and it needs people to lead. And it needs people to actually see the potential that technology is going to bring to our sector. And that's what's next. We've all got the potential to be leaders, and I think we need to widen our horizons, start to set out what we think is the future. And it is about data, it is about process, it is about QA, it's about all of those things, but more importantly, it's how it's going to transform our industry into the next century. And what I mean by century is, in the next few years, we are going to catch. I think we're still in the 1990s personally, and we've been playing with this over the last 10 or 15 years, but the momentum is going to take over. So, thank you for listening to me. Thank you very much for inviting me along. I hope you found that reasonably interesting. I've enjoyed putting the slide pack together, and it's challenged some of my thinking. And one last thought really is, don't be afraid to go and get 360 feedback. People that you're working with, go and ask them what they want. If it's a client or it's a partner in the industry, go and ask them what they want. Go and ask them how we can work together smarter. Find out what isn't working, find out what is, and just keep talking to people. Thank you.